So to start with this, what is the very first thing that I'm concerned about when I'm looking at a fraction and I'm about to add or subtract, whether it's a mixed number or whether it's a regular fraction? First thing I'm concerned about, Shahad.
Common denominator.
Common denominator. Now, I don't care which method you use to find it. Some people will be able to look at 6 and 4 and tell right away it's going to be 12. Because 4, 8, 12, 6, 12, it's pretty quick. Other people are going to use the multiples way, that's fine. I'm going to use prime factorization every time because I think it's the most useful. So, to find common denominators, I'm going to go like this, 4 and 6. 2 goes into both, that's going to be 2 and 3. And now everything's prime, so I'm done. Okay? 2 times 2 times 3 is going to be my my common denominator. Do you understand why I can stop there?
Yeah, but can you do like...
Because ultimately what's going to happen, sorry Shahad, ultimately what's going to happen is I'm going to put a 2 over here, and, or sorry, not there. So that's going to become a 1, that's going to become a 3, stay a 3, and then I'll put a 3 here, and that's going to work out, right? Now, the reason why you can stop is because all I did was move a 2 and a 3 over. The reason why you might want to keep going is because this tells you what to multiply your old fraction by to turn it into your new fraction. Does that make sense? So 1/4 is going to become something over 12. Sorry, 2 times 2 times 3 equals 12. So that's my new denominator. So 1/4 is going to become something over 12. For the 4, I start here, I go to the x. Sorry, this was a mistake. It's not an x. This is the x. I move over, I multiplied by 3. So that's a times 3 and a times 3, so it's going to now be 3 over 12. The other one was a 6. So 5 over 6 is going to become something over 12. Now, if you know in your head already that, well, I doubled 6 to make 12, I'm going to double 5. Some of you might not know that right away, so if not, you use this tool. Find the x, move over, times 2. So that's what I'm doing. Times 2, times 2. Just give me 1 second. So I have 10 over 12 and 3 over 12. God.
The way I did it is, like, I did that, like the new way,
Mm-hmm.
and then I didn't change the top numbers, I just left the bottom.
For sure. If you only change the bottoms, you're wrong. And I'll explain why really quick. Because think about it this way. Let's say I had this pizza, and I want to eat this much.
Okay.
How many slices am I eating right now?
1.
1, right? If I change the bottom, though, or sorry, if I change the number of slices and do this, right? Am I still only eating 1 slice? No, I changed the bottom of my fraction. It was 2, now it's 4.
Yeah, but you still haven't said
But how many are colored in now, Shahad?
2.
2, not 1. So I also changed the top. I changed the bottom from 2 to 4, but how many colored in? It changes from 1 to 2.
But you're still having the same amount.
Right, and these are still saying the same amount. This is the same amount as this. This, when I change it to this, it's going to be the same amount, it's just that the bottoms are the same. Because once the bottoms are the same, I can compare them fairly. I can compare a 12th to a 12th. I can't compare a 1/4 to a 1/6. It's too hard that way. Does that make sense? So, I now have that, so I'm going to deal with my fractions first, because that's generally what I like to do. Good morning. So, my 1/4 changed into 3 over 12, and my 5 over 6 changed into 10 over 12. What's the issue going to be? Chantal. For sure. The 3/12 is smaller than the 10/12. I can't take 10 away from 3. So, just like Chantal said, we're going to now regroup. Because this was 7 and 3/12.
Dang it, no, it was right.
Take away what's now 3 and 10/12. So what I'm going to do is I'm actually going to regroup from that 7. That's going to become 6. Because I'm taking 1 whole pizza, effectively. And I'm going to add it to the fraction.
4 over 2.
Now what goes on top? I'm not going to add 1 on top.
But you took 1 whole.
Yeah, what does that 1 whole actually equal? In terms of over 12.
12 over 12.
Yeah, it equals 12 over 12. So when I borrow the 1/12 from here, that 7 becomes a 6. But I'm going to take 12 over 12, because that's what that 1 whole is, and I'm going to add it to this. So that's going to become, like many of you have been whispering, 15 over 12. Take away 3, and 10 over 12. Now I can really start to work in a way that's a little bit easier here. I can deal with my fractions first if I want, but really I could do all of it. I can do 6 minus 3, because that's my whole numbers, right? And I can also do a 15 over 12 minus a 10 over 12.
Did you do 3 plus 12 and then you get 15?
Correct. Because, and just to clarify, there's 3 over 12 here, it wasn't enough, so I took 12 12 twelfths from here and put it on top.
And then you add.
But that makes that 6, right? Because that's where that 12 twelfths came from. So now it's this 3 plus this kind of 12. Does that make sense? Good. So now, I just finished. 6 minus 3 is 3. 15 minus 10 is 5 over 12. Does that make sense? Good.